Hello. In this lecture, I'll be giving you an introduction to the mole concept and Avogadro's number. And first of all, I'll simply state the Avogadro's number. The Avogadro's number is 6.022. That's not clear. 6.022 into 10 raised to 23. That is the Avogadro's number. Okay, we need that, so I'll put it in a box. Yes, a box. Okay, now that is Avogadro's number. Now, what is this mole concept? If you search in the Wikipedia, you'll get it like this. Write it down. We'll get it as 1 mole of 1 mole of carbon 12. 1 mole of carbon 12 atoms is 12 grams. 1 mole of carbon 12 atoms is 12 grams. Now, what does that say? It simply means that if you take 1 mole, if you simply take 1 mole of any substance, if you take 1 mole of any substance, it will be equal to the atomic mass number, grams. Atomic mass number in grams. Now that is the basic idea of atomic mass unit. For example, I'll give you a more broad explanation, with examples. If you take 1 mole of let's see, if you take 1 mole of oxygen, now what is the atomic mass of oxygen? It's 18. You take 1 mole of oxygen, you will have 18 grams. 18 grams of oxygen. Now, what is 1 mole? 1 mole also has another definition. 1 mole is equal to the Avogadro's number, 6.022 into 10 raised to 23. Now, what? Avogadro's number, what? 1 mole is equal to what? That much particles. 1 mole is equal to that much particles. Now I will explain some more. You don't need this. I'll just remove this. No, you know what? I won't remove it. It's quite important. I'll just arrange this. Yeah, I don't need this one. Yes. I'll move this towards the side. I'll move this towards here. I'll move this here, and I will move this here. Okay. Now, one more possible explanation. 1 mole is equal to 6.022 particles, right? Particles. Why didn't I complete that? Particles. Now, what does that mean? Particles, it can be anything, right? Particles can be electrons, it can be atoms, it can be the neutrons, it can be the quarks, it can be gluons. Okay, 6.022. For example, I'll say if you take, I'll do it in another color. If you take 1 mole of H2O, it means that you will have, I will just copy paste that. It's quite hard, right? Such a big number. You will have 6.022 into 10 raised to 23 molecules of H2O in it. Now that is the idea of mole concept. Now this will also be equal to the atomic or the molecular mass you know what is the molecular mass of H2O? What is the molecular mass? This is H2 is 2 plus oxygen 16. 18 will be equal to 18 gram of H2O. So for example, if you take 18 gram of H2O, you will have 6.022 into 10 to 23 particles in it, and you will have exactly 1 mole of H2O. If someone asks you to give them 1 mole of water, you just give them 18 grams, or 1 mole of some other liquid. You just find the molecular mass of it. Okay, now it might be hard to digest that. Why do we have this whole mole concept? Kinda looks unnecessary, right? Now I hope you have finished with all these. I'll remove all these. Let the Avogadro's number remain. Why do we need that? Why do we need it? Why do we need the mole concept? It's quite hard, and it might seem quite unnecessary, right? Now it is why we need it. It is because mole is just a way of translating between grams and AMU. See, mole is just a way of translating between grams and AMUs. And you see, why do we need that? Because the mass of an electron is not something we can calculate. I mean, as a whole number. For example, I'll write the accurate mass of it. I'll write it in another color. 1 atomic mass unit, that is 1 AMU, is equal to 1.6605389 into 10 raised to negative 24 grams. Now that is quite difficult to calculate when you do it for different elements or compounds or molecules. So that is why we have AMUs, and we need to convert from AMU to grams, right? Now mole is just a method for translating between them. I hope you have got an idea of what mole is. Now you like telling 1 mole is 6.022 into 10 raised to 23 particles is somewhat similar to saying that 1 dozen is equal to 12. For example, 1 dozen eggs is equal to 12 eggs. Somewhat similar. Now I found this very easy way to convert between these mole particles. Just twist around with mole particles and the grams. Okay, I got it from a website. I don't actually remember the name. It's quite very quite a very easy way and very helpful. Okay, consider this. We need 3 boxes. Yes. Okay. Now this box will have what will it have? I need a smaller size. Yes. The grams. Gram of substance. The gram of substance. Let this box be the gram of substance. Now let this box be the moles of substance. Number of moles of substance. And let this box be what? Number of atoms bar molecules. You know what? I'll write it below. Let it be like this. Okay, we need some arrows between them to convert them, right? We need one like this. Wait. Paint has this tool which will help me a lot. Yes, to this. And we need an arrow from here to this. And we need an opposite arrow from here to here. From here to here too. Okay, now how do you convert, if you're given the gram of a substance, how do you convert it to moles? How do you convert it to moles? We simply, what do? We we can. I was looking for the division sign in the keyboard. There is actually no division sign, it's actually a slash. I will write it: divide by molar mass, that is the molecular mass. If you divide it, if you're given the gram of substance and divide it by the molar mass, you'll get the number of moles. Okay, now how do you convert from moles of a substance to the number of particles, or the number of atoms or molecules? I'll write it down. Yes, into Avogadro's number. That's how we do it. That's how you do it. If you're given the moles of a substance, you just multiply it by the Avogadro's number to get the number of atoms or molecules. Now, to reverse it, you just have to divide it, right? Okay. Yes. You know what? I'll just copy paste this. Yes. And I will rub the multiplication symbol and put a division 1 of my own. You just divide it by the Avogadro's number. If you're given the number of atoms or molecules, you divide it by the Avogadro's number and you get the number of moles of a substance. And over here, just the opposite step, multiply it by the molar mass, not divide. This, you just have to multiply it back to get back what you divided. So if you're given the moles of a substance, you multiply it by the molar mass to find the actual gram of a substance in a particular problem. So this is an easy method which I came across while searching. I had this exam and I had to find an easy way to convert them, and it's quite confusing. So you just by heart this figure, or you just take a printout or draw it once more. So we'll teach you more in the next lecture. Bye.